So when chlorine reacts with concentrated alkali, then it will form chloride and chlorate ion. Now I am going to tell you how this is the disproportionation. So this is the chlorine molecule and in homoatomic molecular form, oxidation number of element is 0. Means in Cl2 oxidation number of chlorine is 0. In chloride ion its oxidation number is -1. In chlorate ion, chlorine will show variable oxidation state in its oxide as well as in oxy acid. So it is the compound of chlorine with the oxygen. It means here chlorine will show variable oxidation number. So we will calculate oxidation number of chlorine. So let oxidation number of chlorine is X and oxidation number of oxygen in its compound is -2 for one oxygen atom. So there are 3 oxygen atoms, so it is -6 and total of oxidation number is equal to the charge. So its total charge is -1. In this way we will get X -6 equals to -1. So this 6 will be transferred to this side and becomes +6. So it is X equals to -1 plus 6 and this X will be equals to +5. Means in Cl2 molecule chlorine have oxidation number of 0, but when it reacts with that concentrated alkali, then it will form chloride ion and the oxidation number is -1 and it forms chlorate ion in which oxidation number of chlorine is +5. So in this reaction oxidation number of chlorine of Cl2 decreases in Cl minus and increases in ClO3 minus. In this way there is increase as well as decrease in oxidation number of a particular element in 2 different products has taken place. So this reaction is the disproportionation reaction. So after that now we are going to discuss now we are going to balance this reaction. So I am writing this again and then after we will balance this. So it is Cl2 plus Cl2 and it reacts with hot and concentrated alkali and after that it will form Cl minus and plus ClO3 minus. Students, we will balance this reaction by oxidation number method and for this we split the Cl2 into 2 chlorine atoms. So after that this reaction will be written as Cl plus Cl. This will give Cl minus and ClO3 minus and this OH indicates you have to give answer in basic medium. Means we have to balance the reaction in basic medium. Now we are having the 2 reactions where one of the chlorine is converted into Cl minus. In other reaction Cl converted into the ClO3 minus. So it is the elemental form and in elemental form oxidation number is 0 and it is the elemental ion, so its oxidation is equals to its magnitude of charge. Again this is the elemental form, so its oxidation number will be 0 and we have calculated oxidation number of chlorine in ClO3 is +5. So in this way in conversion of Cl to Cl minus there is change in oxidation number of 1 and in conversion of Cl to ClO3 minus change in oxidation number of 5. Now this changes are cross multiplied, means after the cross multiplication we get 5Cl plus 1Cl. This will give 5 times of Cl minus plus 1 times of ClO3 minus. Student, this step came from cross multiplication of these changes. Means the change of the reaction of Cl2 to Cl to Cl minus will be multiplied to Cl to ClO3 minus and vice versa. So we will get this reaction. After that this 5Cl plus 1Cl this will combine to form 3Cl2 which will give 5 times of Cl minus 1. I am doing it this in a fresh page. Okay, so after cross multiplication we get 5Cl plus 1Cl. This will give 5Cl minus plus 1ClO3 minus. So this 5 plus 1Cl will combine to form 6Cl atoms, and this Cl atom will form 3 molecules of Cl2 because chlorine exists in the molecular form. They do not exist in the atomic form. So this 3Cl2 has given 5 times of Cl minus and 1 times of ClO3 minus. So after the cross multiplication we will balance the oxygen. So on reactant side there are 3 oxygen atoms. On product side there are 3 oxygen atoms and 0 oxygen atoms are present on reactant side. As I told you in the previous video, previous lectures, oxygen can be balanced with the help of water. So if this side is deficient with the 3 oxygen, means there will be addition of 3 water molecule which takes place on reactant side. So after the addition of 3 water molecule, the reaction is 3 times of H2O plus 3 times of Cl2. This will give 5 times of Cl minus plus 1 times of ClO3 minus. After the addition of 3 times of water molecule on reactant side, now reactant side having 6 times of hydrogen. There is no hydrogen is present on the product side. It means product side is deficient with the help of 6 hydrogen atom, and hydrogen atoms are balanced with the help of proton. So we have to add 6 protons on product side. In this way now this reaction is balanced according to acidic medium. But we have question is in the basic medium, so we will add 6 times of OH minus on both sides. Means we will have to add 6 times of OH minus on reactant as well as product side. So after the addition of 6 times of OH minus, the final equation is this: 6 times of OH minus plus 3 times of water plus 3 times of Cl2. This will give 5 times of Cl minus, 1 times of ClO3 minus, 6 times of H plus and 6 times of OH minus. As you know, 1 H plus and OH minus will give 1 water. So there is 6 H plus and 6 OH minus. So they will give 6 water. So there are 6 water on the product side and 3 water on the reactant side. So 3 water will be cancelled from product side. So finally we get the reaction 6 times of OH minus plus 3 times of Cl2. This will give 5 times of Cl minus plus 1 times of ClO3 minus plus 3 times of water. So now it is the final balanced reaction, and this can be checked with the help of total charge. So on reactant side total charge is 6 minus, and on product side there is 5 minus plus 1 minus. So both sides have equal charge, that is 6 minus. It means now this reaction is balanced, means ये reaction balance हो गया. ठीक है स्टूडेंट, मैं आपको फिर बता दूं, ये समराइज कर रहा हूं. आप ऑक्सीडेशन नंबर मेथड से कैसे रिएक्शन को बैलेंस करेंगे. सबसे पहले आप रिएक्शन देखेंगे और ऑक्सीजन हाइड्रोजन के अलावा जितने भी एलिमेंट्स हैं, you have to balance that element by simple multiplication. After the balancing of each and every element except oxygen and hydrogen, you have to select 2 half reaction, or criteria for selection of half reaction is reactant and product of one element is considered as one reaction. फिर हम क्या करेंगे, 2 हाफ रिएक्शन सेलेक्ट करने के बाद जो भी एलिमेंट जिसके अकॉर्डिंग हमने हाफ रिएक्शन को कंसीडर किया है, हम उसका ऑक्सीडेशन नंबर कैलकुलेट करेंगे रिएक्टेंट और प्रोडक्ट साइड, एंड देन आफ्टर चेंज. तो इस तरीके से हम दोनों हाफ रिएक्शन का चेंज कैलकुलेट करेंगे, एंड देन आफ्टर चेंजेस कैन बी क्रॉस मल्टीप्लाइड. मींस change of oxidation of one reaction will be multiplied to second, and change of oxidation number of second reaction will be multiplied to first. After the cross multiplication we will count total number of oxygen. If any side is vacant, deficient with the oxygen, then add water equal to number of oxygen deficient. Then after addition of water, one side will be deficient with the hydrogen. So you have to balance hydrogen with the help of proton. If this reaction is in acidic medium, so this is the final step, and after that you will get the final balanced equation. But if reaction is in basic medium, then you have to add H plus, number of H plus, sorry, you have to add number of OH minus and equal to H plus present in the reaction on both sides. Then after one step, you will get the final balanced equation. So this is the balancing of reaction only redox cases. Now I am going to discuss from advanced point of view. In JEE Advanced sometime question came in which one of the reaction have one redox case and other is the non-redox case. Means the one element is there in which one of the product its oxidation number will be changes, in other product its oxidation number will remain constant. So now I am going to discuss balancing of redox as well as non-redox reaction. Balancing of reaction with redox and non-redox cases. मीन्स हम ऐसे रिएक्शन को बैलेंस करेंगे जहां पर किसी एलिमेंट के लिए रिएक्शन रिडॉक्स भी होगा और नॉन रिडॉक्स भी होगा। मीन्स उस पर्टिकुलर एलिमेंट का एक प्रोडक्ट में ऑक्सीडेशन नंबर वेरी करेगा, दूसरे में ऑक्सीडेशन नंबर कांस्टेंट रहेगा। तो देखिए सबसे पहले तो हम आते हैं इस तरीके की रिएक्शन हमें मिलेगी कब, तो दिस टाइप ऑफ रिएक्शंस आर व्हेन नाइट्रिक एसिड will react with the metal. So nitric acid reacts in two conditions. One is the diluted form and other is the concentrated form. So I am discussing its reaction with the zinc. So if concentrated nitric acid reacts with the any metal, then it will give its nitrate along with the NO2 and water. So this is the zinc. Now this zinc reacts with the concentrated nitric acid. So when this zinc reacts with the concentrated nitric acid, it leads to the formation of zinc nitrate, that is ZnNO3 whole twice. Then after there is formation of NO2, that is nitrogen dioxide, along with the water. Okay. So you have to consider only this as your reaction. Because water can be balanced, number of water can be balanced by balancing the number of oxygen. So net reaction for balancing is this zinc plus concentrated nitric acid. This will give zinc nitrate plus NO2. Now, in this reaction, zinc is in elemental form. So oxidation number of zinc in this reaction is 0. Now moving towards the nitric acid. In nitric acid, oxidation number of nitrogen. So hydrogen has the oxidation number of +1. Net oxidation number of nitrogen is X, and oxidation number of oxygen is -2 for one atom. Now there are 3 atoms, so it is -6. And total oxidation number is equals to total charge, and it is neutral, so total charge will be 0. In this way, we will get X minus I equals to 0. Then after we will get X equals to plus I. Means in this reaction, oxidation number of nitrogen is plus 5. Then after, in zinc nitrate, nitrogen having the oxidation number of +2, and in nitrate and nitrogen having oxidation number of +5, and in nitrogen dioxide, so oxidation number of nitrogen is X. For 2 oxygen atoms it is -4 and equals to total charge, so it is equals to X equals to 4. So in this way, see the reaction carefully. In nitric acid, nitrogen having the oxidation number of +5. In zinc nitrate, oxidation number of nitrogen is constant, but in nitrogen dioxide, its oxidation number is variable. So you are going to solve that reaction in which for one element reaction is redox as well as non-redox. So student, don't be panic. You have to start this reaction like you have solved normal redox reaction. First of all, you have to categorize two reactions. So one reaction is zinc to zinc nitrate and other reaction is nitric acid to nitrogen dioxide. So one reaction is categorized on the basis of zinc. So oxidation number can be calculated on the change in oxidation number is calculated from zinc. So oxidation number of zinc changes from 0 to 2. It means in this reaction change in oxidation number is 2. Second reaction is categorized on the basis of nitrogen. So its reactant side its oxidation number is +5 and product side there is 1. So there is change in oxidation number of 1. So after calculating the change in oxidation number, you have to cross multiply these changes. So this 2 will be multiplied to nitric acid reaction and 1 will be multiplied to the zinc reaction. So after the cross multiplication we get zinc plus 2 times of HNO3. This will give zinc nitrate plus 2 times of NO2 and then after it's water. So don't write water because you have to maintain the number of water by balancing the number of oxygen. So after cross multiplication you have to count total number of nitrogen or you have to count the total number of atom for which reaction is redox as well as non-redox. So its number is 2 in reactant side and in product side it is 2 and plus 2. So its number is 4. Okay. So on product side there are 4 nitrogen and reactant side there is 2. So in reaction source of nitrogen is nitric acid. So 4 nitrogen will come from 4 times of nitric acid means we have to simply add 2 times of nitric acid on reactant side and after the addition of 2 times of nitric acid we get Zn plus 4 times of nitric acid. This will give ZnNO3 whole twice that is zinc nitrate plus 2 times of NO2. Now this reaction is balanced on point of view of zinc as well as nitrogen. Now moving towards the balancing of oxygen. So in product side there is 12 oxygen. Now move towards the reactant side. In reactant side there are 12 oxygen. Moving towards the product side it is 3 2 6 and 2 2 4. Means product side having the 4 oxygen. So in this side there are 12 oxygen and this side there is 10. So 2 oxygen are deficient on the product side. So this number of oxygen can be maintained by addition of 2 water. So after the addition of water, now this reaction is balanced. ये reaction पूरा बैलेंस हो गया है. कई बार क्या होता है रिएक्शन गलत होने का रीजन स्टूडेंट कि हम जैसे ही वाटर ऐड करते हैं अपोजिट साइड में H+ लिखना शुरू कर देते हैं. तो अपोजिट साइड में आप H+ तब लिखोगे जब आप टोटल नंबर ऑफ हाइड्रोजन को काउंट कर देंगे. चलिए हम काउंट कर देते हैं. 1 zinc in reactant side there is 1 zinc, 4 hydrogen, 4 nitrogen and 12 oxygen. Now on product side 1 zinc, 2 2 4 nitrogen and total of 12 oxygen and 4 hydrogen. तो ये रिएक्शन पूरी तरीके से बैलेंस है और चार्ज वाइज भी आप देख लीजिए. ऑन reactant side there is 0 charge, again on product side there is 0 charge. Means both sides are neutral. तो चार्ज के पॉइंट ऑफ व्यू से, एटम्स के पॉइंट ऑफ व्यू से, हर पॉइंट ऑफ व्यू से ये रिएक्शन बैलेंस है. मैं फिर बता रहा हूं ये किस तरीके का केस था. देखिए हम यहाँ पे इस तरीके का केस डिस्कस कर रहे थे जब एक एलिमेंट का रिएक्टेंट के एक एलिमेंट के लिए एक प्रोडक्ट में ऑक्सीडेशन नंबर कांस्टेंट होगा, दूसरे में ऑक्सीडेशन नंबर वेरिएबल होगा. तो आप क्या करेंगे इसको नॉर्मल रेडॉक्स रिएक्शन की तरह बैलेंस करेंगे और आप दो हाफ रेडॉक्स रिएक्शंस को कैटेगराइज कर लोगे. तो एक हाफ रेडॉक्स बनेगा जिंक से जिंक नाइट्रेट. ये जिंक का ऑक्सीडेशन नंबर चेंज होगा. और एक हाफ रिएक्शन बनेगा नाइट्रिक एसिड टू नाइट्रोजन डाइऑक्साइड। नाइट्रिक एसिड से जिंक नाइट्रेट आप नहीं बना पाओगे क्योंकि ये रिडॉक्स रिएक्शन है कि नहीं, ऑक्सीडेशन नंबर नाइट्रोजन का कांस्टेंट है। तो आपने दो हाफ रिएक्शंस बनाई, देन आफ्टर यू हैव टू कैलकुलेट द चेंजेस एंड देन आफ्टर यू हैव टू क्रॉस मल्टीप्लाई दीज। तो क्रॉस मल्टीप्लिकेशन कर लिया, देन आफ्टर क्रॉस मल्टीप्लिकेशन यू हैव टू ऐड टोटल नंबर ऑफ दैट एलिमेंट for which reaction is redox as well as non-redox on both sides. So after the addition we get there are 4 types of nitrogen on product side, but there are 2 types of nitrogen in reactant. So source of nitrogen in reactant is nitric acid, and this 4 can be maintained by addition of 2 types of nitric acid on the reactant side. So after the addition of 2 types of nitric acid we get the final reaction. Zn plus 4 types of nitric acid will give zinc nitrate plus 2 types of NO2. After the maintenance means after the balancing of zinc and nitrogen, we have to balance the oxygen. So this is 4 into 3 means there are 12 oxygen atom on reactant side, and on product 3 to the 6 or 4 10. There are 10 oxygen means product side is deficient with the 2 oxygen. So 2 water will be added on the product side. और जब water आप ऐड करिए तो ये चीज देख लीजिए कि there is need to balance hydrogen or not. अगर need नहीं है then don't be panic for the balancing of hydrogen. अगर वो already balanced है आप ऐड करोगे then आप कभी भी उसके चार्ज को बैलेंस नहीं कर पाएंगे और आपकी फाइनल रिएक्शन बैलेंस नहीं होगी। तो इस तरीके का आप करेंगे नहीं। हम एक आध रिएक्शन पे और डिस्कशन करते हैं। So मैंने आपको फॉर्मेट रिएक्शन बोला, whenever any metal reacts with the concentrated nitric acid, then there will be formation of its nitrate along with the formation of NO2 and water. Now moving towards the dilute nitric acid. So dilute nitric acid reacts with metal in different ways. If it reacts with the more reactive metal, then side product will be N2O. If it reacts with the less reactive metal, then side product will be NO, that is nitric oxide. So I am going to discuss one reaction with the help of copper. So it is copper and it reacts with the dilute nitric acid. So after the reaction of copper with the dilute nitric acid, we get CuNO3 whole twice plus NO and plus H2O. Okay, so please ignore the water. So after the ignorance of water we have final reaction copper plus nitric acid, that will give copper nitrate, that is cupric nitrate plus nitric oxide. So this one is the reaction which you are going to balance, because water can be balanced by the balancing of oxygen. So please ignore that. Okay, so categorize the reaction or listen. Before categorization you have to calculate the element for which you don't know the oxidation number. So in this slide copper is in elemental form, so its oxidation number is 0. In nitric acid we know the oxidation number of hydrogen as well as oxygen, so we will calculate the oxidation number of nitrogen, which is plus 5 in nitric acid. Now in cupric nitrate copper has the oxidation number of plus 2, so copper has the oxidation number of plus 2. In nitrate and zinc nitrogen again have the oxidation number of plus 5, and in nitric acid nitrogen have the oxidation number of plus 2. So in this reaction we are going to categorize 2 redox. So one redox will be copper to copper nitrate, because if we consider nitric acid to copper nitrate, then oxidation number of nitrogen is constant, then that reaction will not be a redox, and we are going to categorize the redox reaction. And second reaction will be nitric acid to nitric oxide. In first reaction change in oxidation number is 2, and in second reaction change in oxidation number is 3. So after that we will cross multiply these changes. So after the cross multiplication 3 times of Cu and O3 whole twice plus 2 times of NO. After the cross multiplication, we are going to calculate the number of that element for which reaction is redox as well as non-redox. So this element is nitrogen and it is 2 times on reactant side. Now calculating product side also. So it is 2 into 3 means 6 or 2 8 means there are total 8 nitrogen atoms on product side. So if reaction is totally balanced, then there will be 8 nitrogen on reactant side also, and you know the source of nitrogen on reactant side is the nitric acid. So we have to add 6 more nitric acid on the reactant side. So after the addition, the final reaction is 3 copper plus 8 times of nitric acid. This will give 3 times of cupric nitrate plus 2 times of NO. So after the balancing of nitrogen, now we are going to balance total number of oxygen. So on reactant side, total number of oxygen is 8 3 24. Now we are going to calculate in product also. So it is 3 2 6 and 3 18 or 220. So product side having the 20 oxygen atom, reactant side there is 24. Means the product side is deficient with the 4 oxygen, and you know oxygen is balanced with the help of water. Now we are going to add, or now I am going to add 4 times of water on product side. So it is 4 water, and after the addition of 4 water, now this reaction is balanced. Now we are going to check this. So 3 copper on reactant and 3 copper in the product. 8 nitrogen in the reactant, 8 nitrogen in product, 24 oxygen in reactant, 24 oxygen in product, and 8 hydrogen on reactant and 8 hydrogen on product. Then after, reactant side is neutral and product side is also neutral. In this way, this reaction is also balanced. तो स्टूडेंट्स मैं फाइनली कंक्लूड करूंगा कि आप चाहे रिडॉक्स को बैलेंस करिए, डिस्प्रोपोर्शनेशन को बैलेंस करिए और रिडॉक्स एज वेल एज नॉन रिडॉक्स को बैलेंस करिए, सबसे बेस्ट मेथड होता है ऑक्सीडेशन नंबर मेथड. ऑक्सीडेशन नंबर मेथड 1 से 2 मिनट के अंदर आपको आंसर दे देगा. 1 मिनट भी मैं ज्यादा बोल रहा हूं, आप एफिशिएंटली करेंगे विद इन 1 मिनट you will get the answer. But if you are trying from ion electron method, then it will be lengthy or it will take more time. So for you and for competitive point of view, more important method is the oxidation number method. Thank you so much.